Alright, so for tomorrow's stick test on related rates, it says two cars are approaching the same intersection. So if I can draw a picture of this. A southbound car is traveling at a rate of 17 meters per second. So there's a car this way, traveling this way at a rate of 17 meters per second. And it says an eastbound car is traveling at a rate of 13 meters per second. So there's another car over here traveling this way at a rate of 13 meters per second. It says, how fast is the distance between the cars changing when the southbound car is 600 meters north of the intersection and the eastbound car is 450 meters west of the intersection. So essentially, this length here is 600 meters because it's 600 meters north. And this length here is 450 because it's 450 meters west. And the distance between the cars is the hypotenuse. So if you use the Pythagorean Theorem, you get, I'll do this in a calculator really quick. And you will not need to use a calculator on the test tomorrow. So 450 squared, this one's out of batteries. Let's try that again. Alright, 450 squared plus 600 squared, square root of that is 750. So the hypotenuse is 750 meters at this time. So they want to know how fast the distance between the cars is changing. So in other words, how fast is the hypotenuse growing or shrinking at this moment in time. So remember that we start with the original equation. We start with, and I'll do it in black so you guys can see a little better, a squared plus b squared equals c squared. And we take the derivative of each of these. And remember, because we're taking the derivative in relation to time, we need to take it using implicit differentiation. So that would be 2a dA dt plus 2b dB dt equals 2c dc dt. And we know what A is, we know what B is, we know what C is, and we know what dA dt is, and we know what dB dt is. So let's plug everything in. I'll just kind of leave some blanks for right now. So let's fill in A, B, and C first. I know that A is 450, B is 600, C is 750. So 450, 600, 750. And then I know that the rate at which A is changing is 13 meters per second. And the rate at which B is changing is 17 meters per second. Now, one thing we should keep in mind with this is normally there's these key words that kind of tell us if it's getting bigger or smaller, like, you know, increasing or decreasing are obviously words. Here, when it says that the car is traveling at a rate of 17 meters per second south and 13 meters per second east, that doesn't really give us, what can you say? That doesn't really give us a sign as far as positive or negative is concerned. So you have to think about this side, like how far this car is from the intersection. You need to think about if this 17 meters per second is making this side get smaller or making this side get larger. And because he's going towards the intersection, that's making that side get smaller. And then same thing with the 13. Because this car is going towards the intersection, it's making this side get smaller. So he's getting closer and closer than 450 meters instead of getting further away. Which means that these two should be negative when we do that. Because they're essentially decreasing the length of that side. So if we start multiplying for 2 times 450 times negative 13, I get negative 11,700. 2 times 600 times negative 17, negative 20,400. And then 2 times 750 is 1,500. So when we put this in our calculator, we get negative 11,700 minus 20,400 is negative 32,100. And if I divide that by 1500 to get dc dt all by itself, I get that dc dt equals negative 21.4, and the units on that would be meters per second. So essentially the hypotenuse, or the distance between the cars, is decreasing at a rate of negative 21.4 meters per second. Or the cars are getting closer and closer together, essentially. So I can't promise that tomorrow's signature test question is going to be exactly the same, just with different numbers. It might be a different problem, hint, hint. But hopefully you guys have gotten a lot of practice with related rates over the last few days that you feel comfortable with them.